Assalamu alaikum. It's our next lecture, and in this lecture, we are going to solve further problems of chapter number 5 of the book Griffiths. In this lecture, we are going to solve problem 5.6, and what it says, the problem says estimate Lamb shift energy gap between 2s 1 by 2 and 2p 1 by 2 levels in hydrogen using the equation. The equation is given del E Lamb, which is equals to alpha power 5 mc square 1 divided by 4 n cube, k for k and 0. Similarly, the E Lamb means delta E Lamb is also given alpha 5 power 5 mc square multiplied by 1 by 4 n cube. Now this is for k nl plus minus 1 divided by pi multiplied by j plus 1 by 2 multiplied by l plus 1 by 2. This is for j plus minus l plus minus 1 by 2. Understood? Okay, next what you have to find, you have to find the frequency of the photon and the emitted photon. You have to find the frequency of the emitted photon in the transition, in this transition from 2s 1 by 2 and 2p 1 by 2 level. Understood? And the experimental value of the frequency is already given, which is 1057 megahertz. Now you have to find the frequency of the photon. So let's start this problem. Because the transition is from 2s 1 by 2 to 2p 1 by 2, here you can see the value of n is 2. So you can substitute the value n equals to 2. And you also know that your del E Lamb, that is basically equals to alpha 5 mc square 1 divided by 4 into n cube, and the n is 2, so it is 2 cube, and this is k20. Okay, and whereas your k20 concerned, the value of k20 is approximately equals to 13. So what you will get, your elam basically equals to, also you know that the value of this becomes, after substituting, it becomes 13 divided by, substitute this, 2 cube 8, 8 4 is 32, and this is same alpha 5 mc square. Understood? Now what you have to do, you have to find for second case E for P. You can say for this the formula you already know, mc square 1 divided by 4, again n is 2 cube. Now here what you have to do, knl, k n means 2 and l is basically 1. How you can identify your L is 1? Because you know that S is basically in first shell means L equals to 0, and your P, the higher energy state is P, and your P is always at L equals to 1. First excited state, okay, L equals to 1. So that's why K and L becomes K to 1. Understood? Minus 1 by pi, and this is equals to j l plus 1 by 2, and here your l value is 1 plus 1 by 2, so it becomes 3 by 2. You have to put the here 3 by 2 here, 3 by 2 here. Understood? Now you have to substitute. You also know that the value for this k21 is k21 value is very small than 0.05, so you can neglect this. You just have to multiply your this relation by this relation, and you will get the final results of del ep Lamb shift, and that is equals to minus 1 by 32, because you are multiplying this by this, so minus 1 by 32 comes from here, and alpha 5 mc square, and it becomes 2 by 3 pi. Understood? This and 2 becomes upside, becomes 2 by 3 pi, and this minus we multiply with this, alpha power 5 is same, 1 by 32 is as it is. So this is your relation. Now what you have to do, you have to find the Lamb shift, and the Lamb shift, you know that the Lamb shift, you can now say that the Lamb shift, and your Lamb shift, you know that is basically equals to delta E, and it is equals to delta E S minus delta E P. Understood? Now just you have to put and substitute the values. This is for delta ES and this is for delta EP, and after putting the values you will get your Lamb shift delta E, and that is equals to you know that 30, you know that 1 by 32 is common. So how you can substitute it? Like, you can first take this common, alpha 5 mc square is common. So what you can do here, also 1 by 32 is common from both these, so you can take common 1 by 32 alpha 5, okay, alpha 5 mc square, and what is left of this minus this, so here is the term 13 left, so 13 minus minus, and this minus becomes plus, and you will left off with this, so here is 2 divided by 3 pi. Understood? So this is your final relation of the Lamb shift. Now what you have to do here further, as mentioned, that you have to find the frequency. So to find frequency, first you have to find the energy. To find energy, you know that basically alpha equals to 1 by 137, and you also know that mc square basically in electron volts equals to 0.511 into 10 raised to power 6 electron volts. Understood? Now what you have to do is just initialize these values in this formula. You will get with 1 by 32. Alpha means you have to put the value of alpha, which is 1 by 137 power 5, and the value of this 0.511 into 10 raised to power 6, and the answer of this is basically 13.2. So after using these values, the answer of this is 13.2. M naught c square value is this, alpha power 5 is this, 1 by 32 as it is. After finding, you will get your answer, and your answer is basically 4.37 into 10 raised to power minus 6 electron volts. This is the answer of energy. Now because you have to find your frequency, you need frequency, so you know the formula of frequency in terms of energy, delta E equals to h mu, where mu is the frequency. If you want to find mu, becomes equals to delta E divided by h, and you know that h is basically equals to 2 pi h cut. Okay, and just put the values, you will get delta E value, you know that 4.37 into 10 raised to minus 6 divided by 2, and pi value is 3.14 multiplied by h cut, we know that 6.58, yes, 58 into 10 raised to minus 16. Understood? Okay, so this is the value of h cut in terms of sorry, this is the value for h cut in terms of electron volts. Okay, because you know that basically h equals to 6.6 into 10 raised to power minus 34. This is in joules, you have to convert in electron volts. What you have to do, you just have to divide it by electron volts, 1.6 into 10 raised to power minus 19, and you will get your h value, that is equals to 6.58 into 10 raised to power minus 16 electron volts. After putting this value of h here, you will get your final answer, and your frequency mu, is then equals to 1.05 into 10 raised to power 9 hertz. So this is the numerical value which we find, and here is also, you can see the experimental value is also given. This is also approximately equals to this. You can see if this point moves 3 times before, and it becomes 10 raised to power 9 becomes 10 raised to power 6, means mega, so it is 105. Again here is some 7, so this is same frequency as the experimental value of frequency. So this is how you can solve this problem 5.6 of book Griffiths. So we can solve more interesting problems and lectures of this course particle physics. Till then you have to stay tuned with us, and if you have any query related to these lectures, we are also uploading lectures of nuclear tracks, advanced electromagnetic field and waves, and many other interesting lectures. If you have any question, you can leave the comment below. I will definitely answer your questions. So thanks for watching. Stay tuned with us. Allah Hafiz.